All right, this is Andy with Infinity Mapping, and several of you have asked for build videos for the DJI S1000 Plus with the Pixhawk 2 Autopilot, which is up here on the top. I'm not going to disassemble my octocopter in order to demonstrate how I built it again because I don't really have a lot of time for that. But I will show you the components that I used and describe the order in which I built things and how I got everything connected. To start with, the very first thing you'll want to do really is assemble the frame, and there's a lot of good videos from DJI already on YouTube about how to do that, so I'll link to one of those videos. But I won't really go into depth showing you how to connect the landing gear and the arms and all of that. Now, what I will do though is I will explain one of the changes that you have to make with the way you set up the arms when you're going to use the Pixhawk as your autopilot. So you'll see that this is the front of the aircraft, and the DJI has these red plastic bands around the front two arms, and all the other arms are black. The other thing you'll see with the DJI frame is these labels M2, M1, and then on the arms where the propellers are, you'll see that they're labeled clockwise or counterclockwise depending on which direction the motor is going to spin. So with the DJI S1000, if you're using a DJI Autopilot, the order of the arms is going to be that M1 is going to be counterclockwise, M2 is going to be clockwise, M3 is going to be counterclockwise, clockwise, counterclockwise, clockwise, counterclockwise, clockwise, and then again back to counterclockwise. However, the Pixhawk Autopilot and the Arducopter software that runs on it expect the orientation to be reversed. So you, for the Pixhawk, want to have this arm here, so M1, you want to be clockwise, not counterclockwise. So clockwise, counterclockwise, clockwise, counterclockwise, clockwise, counterclockwise, clockwise, counterclockwise. So it's different with the Pixhawk than it would be with the DJI Autopilot. So that's critical, and I'll go into some more depth explaining other aspects that you have to take into account with that. But for now, just know that when you build up the frame, that's the order that you need the arms to be in. The next thing you're going to want to do is you're going to want to get your power module installed and also a voltage sensor. Now, the power module that comes with the Pixhawk 2 also includes a voltage sensor, and it's good for 6-cell batteries now, whereas with the Pixhawk 1 it wasn't. Unfortunately, the max current that it can sense is 90 amps. So I wanted something that could sense better than 90 amps. What I chose was the Mauch, M-A-U-C-H, HS-200 amp voltage sensor and current sensor. That's this guy right here. You can see it. The way that I installed it is you have your red power lead that goes to the battery, and I cut that in half, and I stripped some of the wire, and I soldered the voltage sensor in between the connector for the battery and the wire that goes to the power distribution board. This voltage sensor has a little single red cable that also needs to be soldered in to the power lead as close as you can get it. And it has another cord here that actually connects to the PowerCube from Mauch, which is the PowerCube 2 that is what I'm using. Now, I'll explain more about that in a moment. But once I soldered this in place, I covered the joints with liquid electrical tape and then wrapped it around with standard electrical tape. I chose red electrical tape because the wire is red. So that's the first thing that you need to get installed to provide your voltage and your current sensing. The The actual sensors for voltage and current then get plugged into the Mauch PowerCube 2, which is this device right in here. I'll show you a couple different views of it. So this unit right here, it has a little fan on top, and then in this direction you can see it right here. Now the PowerCube 2 provides power to the Pixhawk, so it's got a voltage cable here that connects to the Pixhawk and provides power to the Pixhawk. It also has operates as a battery elimination circuit to provide power to the rail of the Pixhawk, which, if you've read about what you need in order to be able to trigger your camera with your Pixhawk or provide power to servos and the rail here, you need to power it. So this cord right here, which is plugged into the very last spot on the back of the Pixhawk, is the power cable that goes to the extra spot on the PowerCube 2. Now Mauch also makes a PowerCube 3 and a PowerCube 4 to provide additional power output options. Basically, it's the same as adding additional battery elimination circuits. So it's a very useful tool to include on your DJI spreading wings. So that's those are the two modifications that out of the box need to be installed in order to operate your DJI Spreading Wings 1000 Plus with a Pixhawk 2 Autopilot. In addition to getting that set up, you're also going to want to connect your electronic speed controllers, your ESCs. Now, you'll see here on the S1000, there's actually a built-in circuit board where all of the ESCs terminate, and then you take your individual cords that you have. You can buy them. I think these actually came with the Spreading Wings 1000. Each one of these gets plugged in to an ESC slot and then get wired up and plugged into the back of the Pixhawk. Now, this process is a little bit complicated, and here's why. These ESCs are all labeled M1, M2, M3, M4, M5, M6, M7, M8, just like the motors. And you might think, well, that's great. In the back of the Pixhawk here, you have 1, 2, 3, 4, 5, 6, 7, 8. You would think that spot 1 on the back of the Pixhawk might go to M1, spot 2 might go to M2, and that would be completely wrong. So I'm going to be creating a separate document at some point for you to show you exactly what the map is for how to hook those up. But in the interim, you can use the Mission Planner software to test each motor. So you can tell it to spin up motor 1, and then if M1 is actually what spins up when you tell it to spin up motor, actually it's motor A, then that's great. If not, you're gonna have to rearrange your wires. So in a subsequent video, when I explain the software configurations and everything, I'll include that information, but for now, don't assume you can match up 1 to 1, 2 to 2. It won't work. Let's see. Now, as far as other additional things that need to be added in order to make this whole setup work, we have the HERE GPS that came with the Pixhawk 2, connected to a separate GPS mast that did not come with the DJI Spreading Wings. The DJI frame comes with a GPS base, a mast base, but it doesn't come with the actual mast. It expects you're going to get that when you have your DJI GPS, but I didn't buy a DJI GPS, I bought this one, so I had to get a separate mast. This mast was $7.50 on Amazon. I'll include a link for that also. The base unscrews and the whole mast can fold over and lay across the frame, which is nice. So that just gets plugged in to where you would expect it to be plugged in on the Pixhawk, where it says GPS 1. I'm going to be adding an RTK GPS system to this also sometime in the next week, and I'll create a video on how to do that. But for now, I've just got the one GPS that came with the Pixhawk. You will notice something very interesting here. A couple of viewers have already commented on this, that here's the front of the aircraft. The GPS mast has an arrow facing forward that way, But you'll notice that my autopilot is facing backwards and the arrow for the autopilot's facing backwards. Now, the autopilot has a built-in compass and GPS. Well, I don't know about GPS, but it definitely has built-in compass. And obviously the GPS has its own built-in compass. You want them to be oriented in the same direction. So, and at first inspection, that might look a little wonky that I would have my autopilot facing backwards. But there is actually a software configuration option in the autopilot in Mission Planner that allows you to set the orientation of the autopilot. So you can actually set the orientation as yaw 180 degrees, which is what I have done. So that's why it works, just in case you were wondering. Now, other additions, you need to have telemetry if you want to be able to use a ground control or tablet or anything at all to tell what your aircraft is doing. I'm using an older 3D robotics telemetry radio right now just because I had one laying around. I plan on upgrading it sometime in the future, but you know, to something maybe a little bit more high powered that would get better range. But for right now, this radio works really well. It syncs up really well, so I've got no problems with it. I've also placed it on this mounting bracket, which is right next to the motor for the retractable landing gear. At first I was a little bit concerned that there might be some interference there, but it's actually not been a problem. So in addition to my telemetry radio, I've also connected here an FrSky X8R transmitter and controller, basically receiver and transmitter for the Taranis Plus flight controller that I use. You know, it's the thing with the sticks that you fly around with. This particular receiver transmitter is pretty good. It's got 16 channels. Now, it's important to note that if you want this to work properly with your Pixhawk, you want to use your S-Bus connection here directly into the back of your Pixhawk right here. And that will provide you with your telemetry, but it will not provide you with radio control, just telemetry. So that's why I have here a second wire going from the FrSky here. And that wire also goes to the Pixhawk. Let's see if I can find exactly where I have that plugged in at. It's plugged in over here somewhere. That also goes to the Pixhawk, and that provides you with the actual radio control. So you have to have two wires coming out of your FrSky X8R in order to have your telemetry and your radio control with your radio controller. Now, we can talk about the landing gear, the retractable landing gear. So first, for the retractable landing gear to be powered, you have to have it plugged in. There's conveniently a spot located on the frame of the S1000 for power. So I just plug that in there. It gets connected up to the power distribution board, and you don't have to worry about power for your landing gear after that. The landing gear also has, you'll see over here, a spot to plug in a cable to control the landing gear, and you plug this into your autopilot. So this cord didn't come with the S1000. I had to go buy one. It's just a standard positive, negative ground or signal cord. So I just have that routed up into the back of the Pixhawk here. And you can see I've got it plugged in right there. And there's some software configurations that you have to make inside Mission Planner in order to actually get it to control the landing gear. But again, that'll be the next video I think I release. So there we have it. We have our landing gear set up. We have our GPS. We have our radio communication and telemetry. I've explained the orientation difference between the S1000 with the Pixhawk versus the S1000 with the DJI product. And yeah, so the next video will be specifically looking at the software configurations to make this thing actually fly. And sometime in the very near future, I'll be doing an integration with RTK for precise navigation. And just kind of as a side note, in case some of you were wondering why I chose this platform, why I chose this autopilot, my entire intentions for having this system is to be able to do scientific research for geography and environmental studies and climate and that sort of range of things. So in order to be able to do that, I need a system that I can program to do exactly what I want it to do, and also be able to carry the kind of weight and cameras that I want it to carry. So this system does those things. The Pixhawk Autopilot is open source. This is the model that has the Edison module inside, which means that I can do some extra compute processes directly on the Autopilot. Once I have the RTK in, I'll be able to actually navigate back to the same exact location I did the last time using the Autopilot, which is ideal for the kind of research that I'm doing. And you know, DJI's Autopilot system is closed source. They do have an API that allows you to do some things with it, but basically, if you're interested in using your drone for something other than photography and videography for fun, then you're going to want something that is customizable. And that's why I chose the Pixhawk ultimately. So that's it. Thank you for watching this tutorial, and like my video and subscribe if you are so inclined.